Welcome to the Walton Pi. Today we're going to be discussing what it means for something to be a topology. So if X is some set, then a topology T on X is going to be a collection of subsets of X that satisfies the following three conditions. So both X and the empty set are going to be in that collection of subsets. So you have to have both nothing and everything. Next, we need any union of sets that are in T must also be in T. So if A is in T and B is in T, then A union B has to also be in T. Now, this says any union. This allows for us to have an infinite union. Okay, so you can have infinitely many things all unioned together. That has to also be in T. Third, any finite intersection of sets in T is also in T. So that means if you have set A and set B, their intersection, A intersect B, has to also be one of those sets that's in the topology. Now this one has to be a finite intersection. We need to only be allowed to do this over finitely many things. If you allow it over infinitely many things, weird stuff happens and it's not considered a topology. Okay, so let's go through a few examples. So if X is a set, the following are going to be some examples of topologies. So the set of all subsets of X, so the power set of X. This is what's called the discrete topology. Now, let's make sure that this is a topology. Is the empty set an element of the power set? Yes. Is the entire set an element of the power set? Also yes. If I take any collection of those sets and I union them together, is that going to be an element as well? Well, we take any collection of subsets, we union them together. That's going to then be a subset of X, which is going to be in the power set of X. So yes. And then if we take any finite intersection, that's also going to be an element of the power set. So this is a topology, and it is what is known as the discrete topology. Another one is just the set that contains only the empty set and X itself. This is called the indiscrete topology, and it is actually a topology. You have the empty set and you have X. If you take any union, you either took an infinite union of empty sets, which is still the empty set, or at least one of them was X, so then you get X. And if you take the intersection of two things, either you get the empty set or X itself. So this is going to be a topology, and it's called the indiscrete topology. Another one is if you have the set 1, 2, 3, 4, then the collection of the empty set, all of X, the set 1, 2, 3, the set 1, 3, and 4, the set containing 1, the set containing 3, and the set containing 1 and 3, this is a topology. This one takes a little bit more work to check, but if we say, okay, it has the empty set and it has X, okay. If we take any two elements and we look at their union, either their union is going to be something that's already here, or it's going to be all of X, which is also here. And if we take any intersection, that's also going to be an element of this. It takes a little bit of work, so go ahead and pause the video if you want to check that, but this is actually going to be a topology. And this topology is what's known as the pseudo-circle. And it's called that because it shares a couple interesting properties with the circle, even though it's definitely not a circle under most other definitions of a circle. So I hope this was helpful in getting an idea of what a topology is. If there's other things you'd like me to discuss about topologies, leave them in the comment section down below. I will be glad to make a video about those. I hope you have a great rest of your day, and good luck with all of your math.